In August 2025, inside the mission control room for the James Webb Space Telescope, the steady stream of data suddenly stopped. On the central monitor, a single, terse message appeared. Safe mode initiated. The room fell silent. No keyboards clicking, no explanations offered, just the blinking lights reflecting off tense faces. James Webb, the most powerful space telescope ever built by humanity, had just shut down its entire suite of scientific instruments. At first, everyone assumed it was a routine glitch. Webb had entered this protective hibernation a few times before to shield itself from software bugs or data collisions. But this was different. Just before everything went dark, Webb's sensors had registered a strange series of oscillations. It wasn't background noise, nor was it the familiar signal of a pulsar or a natural radio source. It was a structured, rhythmic, repeating wave, precise to 6 decimal places, as if controlled by some unseen machine. The James Webb Space Telescope was never designed to listen. It is humanity's giant eye, peering deep into the past using infrared light, to a time when the first galaxies were still taking shape in the newborn universe. With its 6.5-meter primary mirror and 4 sophisticated scientific instruments, NIR-CAM, NIR-SPEC, MIRI, and FGS-NIRIS, Webb operates like a perfect orchestra. It finds its target, locks on, and then analyzes the composition of incoming light, atom by atom. It doesn't detect radio waves, it doesn't listen, yet on that night, it picked up something that kept a beat. When experts accessed the backup data, the signal was unmistakable, a series of narrow, consistent pulses, each separated by exactly 3/600 seconds, without deviating by even a millisecond. Nothing in nature is that precise. Pulsars spin rapidly, but their rhythm always fluctuates slightly. Waves from supernovas, nebulas, or background radiation are all chaotic. This was not. It was too pure, too deliberate. Less than 10 minutes later, NASA issued a command to lock down the entire data stream to Earth. Freeze telemetry, a standard order for a serious anomaly. But everyone on duty knew this was something far beyond a technical issue. When they triangulated the signal's origin, the result left the entire team speechless. It was coming from the direction of an object that had only been discovered a few weeks prior, 3I Atlas, the third interstellar object ever to pass through our solar system. After Oumuamua and Borisov, 3 Atlas was first spotted in late July 2025 by the University of Hawaii's Atlas Telescope Network. Initially, it was just a faint speck of light moving at high velocity, presumed to be a harmless, drifting comet. But the first images from ground-based observatories gave astronomers pause. Its brightness tripled in just a few hours. Yet it had no dust tail, no gas cloud, no outgassing. Its light wasn't a reflection of the sun. It was being emitted from within, focused, stable, and unnervingly steady. Its luminosity was almost mechanical. When James Webb locked onto 3I Atlas, the spectral data only deepened the mystery. Mixed in with the familiar signatures of water ice and carbon dioxide were spectral lines never seen before, lines that corresponded to metallic alloys and several rare earth elements, substances that could only be forged in industrial furnaces. Other spectral bands showed quantum fluctuations, a hallmark of artificial materials. And it was in the middle of analyzing this data that Webb's system switched to safe mode. The world's most powerful telescope, the eye looking at the dawn of time, suddenly went silent. Back at mission control, experts cycled through every possibility: a cosmic ray, a sensor malfunction, a reflection from a satellite, even radar interference from Earth. Nothing matched. The signal's frequency was located squarely in the quiet zone of the radio spectrum, a band that SETI scientists have long called the water hole. The ideal frequency for sending messages across the cosmos because it suffers the least amount of interference. A few members of the team began to suspect Webb hadn't just misheard. Maybe it had heard something real. In the days that followed, NASA remained silent. No press releases, no press conferences. Just a brief note: James Webb is undergoing scheduled maintenance. But in the astronomy community, rumors spread faster than light. A leaked internal report contained the phrase structured pulse. Anyone who had seen the data understood if this was real. This was no longer about astronomy. At Johns Hopkins University, Dr. Carrie Liss's team, specialists in cometary spectroscopy, had managed to download the data package just before the lockdown, when they reconstructed the energy graph. The pulses appeared like a heartbeat, a gradual rise, a fall, and then silence, just like a signal waiting for a response. 3 days later, all theories of coincidence were shattered. Radio observatories in Chile, South Africa, and Australia detected the same signal sequence fainter, but with the identical waveform. And the most chilling part, they appeared exactly every 72 hours, precise to the second. The scientific community began to fracture. One side insisted it had to be a physical coincidence, a unique Doppler effect as the object moved. The other side, quieter, more cautious, began to use the term technosignature, while no one dared make a definitive claim. All agreed that no natural object had ever exhibited a pattern this precise. Amid the confusion, a closed-door meeting was held between NASA, the European Space Agency, ESA, and the SETI Institute. They decided on a small but audacious step to send a reply. Not a message, just a sequence of prime numbers, the periodic table of elements, and 3 fundamental physical constants. A purely scientific greeting, no symbols, no words. 72 hours later, in the early morning of August 21st, a faint radio pulse returned, arriving in the exact predicted time frame. It was weak, but the wave pattern was a perfect match to the original frequency. Immediately, access to Webb's data was restricted globally. Analysis servers at NASA, ESA, and the Canadian Space Agency were locked down from external access. Reports were sealed. No one outside the core research team knew what had truly been found. The James Webb Space Telescope, humanity's farthest-seeing machine, remained completely silent. And in that silence, a question began to grow. Had we just received the first signal from another intelligence? Or were we just hearing a bizarre echo of ourselves in the cosmos? Whatever the answer, from the moment Webb went dark, humanity had changed. To understand what happened, we have to go back to the nature of Webb itself. It is not a radio antenna. It is an optical machine, tuned to perfection. Every infrared photon that enters its 6.5-meter mirror is reflected to a focal point and channeled through a series of instruments. An IR cam finds the target. FGS locks on to ensure extreme stability. And then NIR, SPEC, and MIRI split the light into hundreds of spectral bands. Each of those spectral lines is a chemical fingerprint from a distant world. It was during this final stage, as the sensors read the raw data from the light, reflecting off 3I Atlas, that the strange pulses appeared. Technically, Webb cannot hear sound, but it can see energy fluctuations over time. Every photon arriving at the telescope is time-stamped, and by arranging them in sequence, computers can create a graph of intensity variation. This is how the analysis team could see the signal's heartbeat. The light from 3I Atlas wasn't continuous. It was pulsing on and off. It was so precise that Webb's noise-filtering algorithms couldn't classify it. The system assumed a software failure and immediately triggered safe mode, the autonomous self-defense state programmed into every spacecraft. Webb's safe mode wasn't a human decision made in the heat of the moment. It was the reaction of an intelligent system. When faced with any signal or data that falls outside valid parameters, Webb automatically shuts down its science instruments, orients its solar panels toward the sun to guarantee power, and locks its antenna toward Earth to await commands. The colossal machine is programmed to protect itself from anything unexplainable, in this case, the very regularity of the signal. The thing humans found so miraculous was flagged by the system as a critical error. NASA engineers once compared safe mode to a pilot closing their eyes in a storm to keep the plane level, not out of panic, but to wait for the storm to pass. This time, however, the storm Webb encountered wasn't physical, it was data. The signal from 3I Atlas immediately drew comparisons to every precedent on record. In 1977, the Big Ear radio telescope in Ohio detected the WOW signal, a powerful 72-second radio burst on the perfect frequency for interstellar communication. Astronomer Jerry Emin, the first to see the data printout, circled the sequence 6EQUJ5 and wrote a single word in the margin, "Wow." But the signal happened only once and never repeated. In science, an unrepeatable event is not evidence, it is only a mystery. 40 years later, humanity encountered that mystery on a different scale. 1 Oumuamua, the first confirmed interstellar object to pass through our solar system. Its bizarre, elongated shape, its odd trajectory, and its non-gravitational acceleration led some scientists, including Harvard's Avi Loeb, to question if it was a form of alien technology, perhaps a light sail. But the data was insufficient, and the scientific community chose the safer explanation, a rare natural phenomenon. 2 years after that, Tui Borisov appeared, trailing gas and dust like a typical comet, dampening some of those bolder theories. And then came 3I Atlas. This object was neither normal like Borisov, nor abnormal like Oumuamua. It had both extreme velocity and spectral signals suggesting artificial materials. Most importantly, it emitted a structured, repeating signal. It was this repetition that made all natural explanations so difficult to defend. In astrophysics, there are plenty of periodic radio sources, pulsars, variable stars, and binary systems all emit regular radiation, but they all share certain traits: limited precision, variation over time, and no capacity for information modulation, an artificial signal. By contrast, typically has 3 characteristics. A narrow bandwidth, meaning the energy is focused on a very small frequency range, like a pure musical note in the chaotic symphony of the universe. A non-natural pattern of modulation or repetition, like a sequence of prime numbers or a mathematical structure. A systematic Doppler shift that reflects the source's movement in a predictable way. The signal from 3I Atlas met all 3 criteria. Its frequency band was extremely narrow. Its repetition was so precise that current human technology would struggle to replicate it in space. And its Doppler shift was consistent with its trajectory deeper into our solar system. If it was natural, it was a miracle of physics. If it was artificial, it was the greatest shock in the history of science. However, scientists know one thing for certain. Extraordinary claims require extraordinary evidence. No one could declare the discovery of extraterrestrial life based on a single repeating pulse. The data had to be independently verified, with all possibilities of interference from Earth, from satellites, and even from Webb's own software ruled out. But with the data channels locked down for security reasons, the scientific community lost access to the primary source for verification. Webb's technical silence quickly became a political one. Some ESA experts suggested Webb had accidentally picked up a reflection from a military satellite or was experiencing sensor overload. But that couldn't explain the precision to 6 decimal places, and especially not the 72-hour reply. If it were interference, it would be random. If it wasn't, it meant someone or something out there was answering. In the following days, dozens of simulations were run. Some proposed that 3I Atlas contained materials that reflected light at a unique frequency, tricking Webb into seeing a structured signal. Others tried to replicate the waveform with radio transmitters on Earth. None succeeded. Meanwhile, Carrie Liss's team, reprocessing the spectral data, discovered another strange detail nestled among the alloy bands were energy lines in the low quantum fluctuation range, consistent with superconducting materials near absolute zero. In nature, that is virtually impossible. At this point, the question was no longer what did Webb hear, but what made Webb react that way. The telescope was programmed without emotion, without fear, but in its behavior that night, shutting down, turning away, and going completely silent, humanity saw a faint reflection of itself, fear of the unknown. Once news of the Webb signal escaped the lab, it spread faster than any communications satellite ever launched into orbit. It started as a few leaked lines on a science forum, a blurry screenshot of the structured pulse log. Within 2 days, the entire internet was on fire. Headlines exploded: James Webb detects repeating signal from deep space. NASA's unusual silence. Could this be the first proof of ET? NASA's official silence only fueled public conviction that something monumental was being hidden. Theories were spun that Webb had received a message, that the government was censoring the data, that humanity had received an answer it wasn't ready to comprehend. Meanwhile, inside the closed-door meetings of research institutes, scientists faced a very different fear, the fear of being wrong. For them, extraordinary claims require extraordinary evidence. A repeating signal, however tantalizing, could still be an equipment error, terrestrial interference, or a bizarre fluke of physics. But for the public, the mere possibility was enough to ignite a firestorm of hope. And when belief is met with silence, it turns into suspicion. In Geneva, the International Astronomical Union convened an emergency meeting. Representatives from NASA, ESA, JAXA, and the SETI Institute were all present. The opening memo was clear: independently verify the origin and potential artificiality of the 3I Atlas signal before any public announcement. According to the International Post-Detection Protocol, any potential signal must go through 4 stages: verification, notification, announcement, and no response without global consensus. This principle was established in the 1980s, when humanity first realized that replying to an alien civilization could be the single most important and most dangerous decision in the history of our species. But the protocol had never been put to the test. Now, for the first time, it was no longer a theoretical exercise. Some scientific groups argued that Webb had simply discovered a new, misunderstood natural phenomenon. Others believed that even if there was only a 1% chance, it was an artificial signal. Humanity had a duty to investigate. But there was a problem: the original data was sealed. NASA cited high-level technology security regulations. ESA called it a standard precaution. And SETI would only say, "We can neither confirm nor deny." In those meeting rooms, every decision was weighed as if standing between two worlds. Announce too early, and if it turned out to be noise, the credibility of the entire scientific community would collapse. Keep it secret for too long, and if it was real, humanity would lose the chance to witness a historic moment. While researchers wrestled with scientific ethics, the outside world was moving on a completely different trajectory. On social media, millions of posts appeared daily. YouTube channels claimed to have decoded Webb's signal, recreating the sound from 3I Atlas, using simulated frequencies. One video hit 10 million views in 24 hours, though it was just an echo crafted from imaginary data. Blogs, podcasts, amateur documentaries all spoke of the day Webb heard the first voice from space, from a potential software bug. The story became a cultural icon. People made music using the 3600-second pattern, printed T-shirts with the phrase, "We are not alone," and wrote poems titled, "Echoes from Atlas," in less than a week. The Webb signal no longer belonged to science, it belonged to all of humanity. Governments began to worry. In Washington, a national security team was formed to assess the potential impact of extraterrestrial intelligence. In Moscow, the space agency Roscosmos announced it would conduct its own independent observations. And in China, the FAST telescope, the world's largest radio dish, suddenly redirected a portion of its observation schedule to the same coordinates where Webb had seen 3I Atlas. No one wanted to be last, but no one wanted to be the one to confirm something they weren't ready to face. Throughout it all, James Webb remained silent. The data stayed locked, its instruments in standby mode. But its silence became an extension of the signal itself. It was as if Webb had not only detected a wave, but had also forced all of humanity to stop and listen. Some philosophers called it a second Copernican moment, a time when humans were displaced from the center of the universe. Not just in space, but in meaning. Since birth, we had always seen ourselves as the ones asking the questions. Now, perhaps, we had become the ones being asked. Amid the noisy debates, a quieter question emerged. If this truly is a greeting, should we answer? In classified drafts, the words were written in the cold language of science. Response is not recommended. Maintain silence until full verification. But outside, Billions of people on Earth were looking up at the sky in a strange, unprecedented silence. Perhaps never before in human history had silence been so full of hope. In another corner of the world, in a small room lit only by a monitor, Dr. Carrie Liss reopened her old data, the last fragment she had managed to save before the servers were locked. The waveform was the same, a steady heartbeat, once every 3,600 seconds. But as she zoomed in on the final section, a tiny fluctuation appeared between two of the pulses, so faint the software had nearly missed it. A slight deviation in the wave, lasting only a few milliseconds, too short to be definitive, but long enough to make her pause. She didn't know if it was a processing error or part of the message, but at that moment, she felt certain that Webb's mission was not over. Perhaps it was just waiting for the next reply. Time passed. No new signals arrived. No further replies came. The headlines that had electrified the internet faded, replaced by more terrestrial stories. But for those who had seen the data, Webb's silence wasn't an ending. It was the beginning of something much larger. Because sometimes, the greatest discovery isn't found in an answer, but in the moment you realize you're being asked a question. For millions of years of evolution, humanity has looked to the sky for an answer to the question, who are we? And on that night, as Webb paused in the void, perhaps the universe answered in its own way, not with words, but with a steady heartbeat in the dark. 3I Atlas is far away now, gone from our system, vanished back into the cold expanse. Maybe it was just an ancient block of ice. Maybe it was the remnant of a civilization that fell silent millions of years ago. But whatever it was, it left a dent in human consciousness, an invisible rhythm that made the entire world listen to the same beat. Because in the moment Webb disconnected, we heard an echo of ourselves, our curiosity, our fear, and our desperate hope that we are not alone. And perhaps that was the real message the universe wanted to send. If the cosmos truly did speak, maybe what it wanted to say wasn't "you are not alone," but rather, "it is time for you to listen, not with radar, but with humility before the infinite." What do you think? If you had the chance to send one message to the universe, what would you say? Let us know in the comments below, because who knows? Perhaps our thoughts today will become the signal that someone out there receives tomorrow. And if you want to continue this journey into the mysteries of space, where science and imagination collide, don't forget to subscribe, like, and share this video. Because out there, the universe is still waiting for us to listen one signal at a time.